Basis of many trig identities is based on the angle addition formulas of sine and cosine, making it critical to understand this proof. Not only will this aid in memorization, but it will make math much more intuitive, and you'll find you can solve problems better and have a deeper understanding of mathematics overall. Without further ado, let's prove these fundamental identities. So before we get started, the one thing that we should take note of is basically a property that we're going to use a lot today. And basically, for a right triangle with an angle of theta and a hypotenuse of r, and let's say it has a side called opposite and another side called adjacent. So the sine of theta is going to be equal to opposite over hypotenuse, which is in this case just going to be r. Whereas the cosine of theta is going to be equal to adjacent over hypotenuse, which is just going to be r. And basically we can multiply r on both sides of this equation to get that opposite equals to r sine theta, and that adjacent equals to r cosine theta. So basically, for the opposite side of an angle in a triangle, it's going to be equal to r, or the hypotenuse, times sine theta, whereas for the adjacent side of the angle theta, it's going to be equal to the length of the hypotenuse multiplied by cosine theta. Alright, so now with that out of the way, we will be able to continue on with the proof. So we're going to start off by constructing this green triangle with, and it's a right triangle with an angle of beta, and we're going to stack a red triangle on top of it with an angle of alpha. And notice that it is also a right triangle. So we're going to say that this red triangle has a hypotenuse of r. So this means that for the opposite side of this red triangle, or the side opposite to alpha, is going to have a length of r sine alpha. Again, we know this from the property that I discussed earlier. And similarly, for the side adjacent to angle alpha, it's going to have a length of r cosine alpha. Now, since basically the adjacent side of alpha is actually the hypotenuse of the green triangle, that means we can figure out the lengths of the legs of the green triangle as well. So we know that the side opposite to beta is going to be r cosine alpha sine beta, and that the side adjacent to angle beta is going to be equal to r cosine alpha times, sorry, it's not supposed to be sine. This is actually supposed to be cosine beta. So the adjacent side of the green triangle relative to angle beta is going to be equal to r cosine alpha cosine beta. So now we're going to basically draw another, we're actually going to construct a line that is perpendicular to this green triangle, and it's going to extend all the way to the red triangle pretty much. And we're also going to draw another line which is perpendicular to the line that we just constructed, and it's going to touch this intersection of the two triangles, this intersection. So notice that these two lines are actually parallel. This white line and this bottom green line, they're actually parallel. So by the alternate interior angles theorem, we know that this angle is also going to be beta. All right, so, and because we know that in this red triangle, do you see how there's we're basically, this angle in total is going to be equal to 90 degrees, right, of the red triangle. So this means that this angle that I drew an angle to, or an arrow to, sorry, is going to have basically a measurement of 90 minus beta. And this makes sense because 90 minus beta plus beta is going to be equal to 90 degrees, which is exactly what we set the triangle up as. All right, so we also have 90 degrees over here, and we have 90 degrees minus beta over here. So what would this angle be, the angle over here? Well, it would also be beta. And this is because the angles in a triangle must add up to 180 degrees. So if you have 90 plus 90 minus beta, that means that this angle right over here has to be beta. All right, so this would mean that this side length right over here, I'm actually going to do this in a different color. This side length from here to there is going to be r sine alpha cosine beta, and that this length, or this leg over here, is going to be equal to r sine alpha, alpha sine beta. So now if you look at this entire leg, you're going to notice that it is composed of this line segment plus this line segment, which means the entire length of this leg is going to be equal to r sine alpha cosine, r sine alpha cosine beta plus r cosine alpha sine beta. Running out of space there. Actually, I'll rewrite it. This entire side length is going to be r sine alpha cosine beta plus r cosine alpha sine beta. So if you'll notice, this white line segment over here is actually just going to be, or this is basically the leg of a bigger triangle that I circled here in white. So now that we know that it's basically a leg of a triangle, and note that the angle is going to be alpha plus beta. So that means that the sine of alpha plus beta is going to be equal to this white leg, this white line segment over r. And notice how there's also a r as a common term in basically in this line segment. So we actually just factor it out as r sine alpha cosine beta plus cosine alpha sine beta. So if you so sine is going to be opposite over hypotenuse, so that's going to be white. It's going to be the white line segment over this line segment. So that's just going to be equal to r sine alpha cosine beta plus cosine alpha sine beta all the way, or it's going to be all over r, because r is the hypotenuse. So notice the r's cancel out. So we get that sine alpha plus beta is going to be equal to sine alpha cosine beta plus cosine alpha sine beta, which is the same as this equation over here. So that's the proof of the sine angle addition. Now I'm kind of running out of space here, so I'm going to erase all this. And we're going to work on the cosines thing now. All right, so if you'll notice, this leg, or sorry, this line segment from here to here is going to be basically the opposite leg of alpha plus beta. So if we want to find the cosine of alpha plus beta, then we're going to have to find the length of this line segment over here. So, and we can do this quite easily actually, because we know that this entire leg is going to be equal to r cosine alpha cosine beta. And that's going to be this entire leg right over here. And this smaller segment, we found the length of up here. It's going to be equal to r sine alpha sine beta. So what this really means is that for this smaller green segment, it's just going to be equal. It's going to be equal to r cosine alpha cosine beta minus r sine alpha sine beta. And we can factor out an r to get that. This is just going to be the length of r cosine alpha cosine beta minus sine alpha sine beta. So in order to find the cosine, I'm actually gonna erase a few things here. So in order to find the cosine of alpha plus beta, which again is just these two angles right over here, we're going to have the opposite over hypotenuse. So that's just going to be this side length that we just found over hypotenuse, over the hypotenuse, which is just r. So we're going to get that this is so that cosine alpha plus beta is going to be equal to r cosine alpha cosine beta minus sine alpha sine beta. And it's going to be all over r. So notice that the r's just cancel out, and you're left with the fact that cosine of alpha plus beta is going to be equal to cosine alpha cosine beta minus sine alpha sine beta, which is just this statement right over here. So that is how you prove the angle addition formulas for sine and cosine. And notice that you can actually just substitute, and if you wanted to find the angle like subtraction or minus or subtraction formulas, you can just add a negative beta. So you can replace all these positive betas with negative betas, and you're going to find that sine alpha minus beta is going to be equal to sine alpha cosine beta. And notice that the beta did actually became positive again because cosine is an even function. So the negatives don't actually matter. And it's going to be minus sine of beta cosine alpha. And this is because, and this minus sine beta is because sine of negative beta is the same as negative sine beta. So that's where you can get the angle subtraction formula for sine. I'm going to do a similar thing with cosine. I'm actually going to erase a few more things. You can replace this beta with a minus beta and replace it for over here as well. And you're going to find that cosine alpha minus beta is going to be equal to cosine alpha cosine beta plus sine alpha sine beta. Again, we know that sine of negative beta is going to be equal to negative sine beta. But this negative sign here multiplied by the negative sign over here is going to make a plus sign. So that's why we have a positive sign instead. So that's pretty much it for the angle addition formulas as well as the angle subtraction formulas. And I hope this video helped you. This video was of value to you, or you like this concise, no BS way of teaching, then please consider supporting the channel. Otherwise, good luck in your studies, and thank you for your attention.